All right, least common multiple, LCM. Let's go. All right, so your first vocabulary today is multiple, and second is common multiple. So we're kind of breaking down the title of our thing here. So a multiple is the product of that number and a whole number. So we all know what multiple is. It's multiplying. So if you take and it's a whole number, so there's no decimals, no fractions. It's got to be a whole number. So a common multiple are numbers that have the same multiples as the one they have in common. So like 5 and 8 down here. 5, 10, 15, 20, 25, 30, 40. And then 8, 16, 24, 30, 40. So we circle the one that is the least common multiple, or that is the common multiple, I should say, between them. It's not quite the least one, because least has a slightly different determination. So a least common multiple and least common denominator, they're kind of the same thing, except one's a fraction, one's not. So a least common multiple is the least common non-zero multiple. All right, and then the least common denominator is two or more fractions in the least common denominator. So if I gave you, like earlier we had 8 and 5. 8 and 5, whoop, there we go. Oh, sorry, 3 and 4, there we go. So I've had multiple. So to find the least common multiple, remember it's a non-zero. So zeros don't count. Whoop. Go back there. Gotta love PowerPoint. Not. So the zeros don't count. So it's whatever is the least common non-zero multiple. But if you have a fraction like this, and we need to find, so same numbers, 3 and 4, they just kind of put the common ones, and you can usually start with multiplying them together. That's always a guarantee. If you multiply them together, that's the least common denominator. But if you get a big number like 20 and 30, you might find something in between there that doesn't, or that would work for them. So just be careful on something like that. But yeah, so you multiply them together, and I'll show you another way to find least common multiple here in a little bit. All right, so what is the least common multiple of 6 and 12? So in order to do that, we just start counting by fours. So I'd go 0, 4, 8, and you can see all the numbers up here. And then, whoop, that's 6 in there. So let's do 12 down here, why not? 12, so I'd have 0, 12, then 24, 36. So multiples of 12. Okay, so the ones they'd have in common would be 14, 12, and then 6 would have 12 and 24. So my least common multiple of 6 and 12 is going to be 12. And there's just another way to come up with multiples. If you multiply, 5 times 0 is this, 5 times 1 is this. Or you can just start with, 0, 5, and then I'd go 10, 15. Those are all ways to come up with multiples. All right, so here's what I was saying earlier about bigger numbers. So now that we understand what a multiple is, or what the least common multiple is, what are we doing with a bigger number like this? Because this one I'm not going to be able to just count the lowest multiple. So it's actually something that we've done earlier. So we're going to start out by prime factoring them. So you would actually take your factor tree, which is I think the easiest way. So you do 168 and 180, and you'd start pulling things out, 2 and 90, 9 and 10, 3 and 3, 2 and 5. And so there would be my numbers there. That's just an example. So we would prime factor that out like this. So 2, 2, 2, 3, that would be 168. So if we had done it up here, if we turn that into exponential form, so 2, 2, 2, so we'd make that an exponential form. So if there's 3 2's, we'd put the exponent up there, and then the singles. We take the one that I just did here, so 2 2's, 2 3's, and a 5, turn that into exponential form. Now, this is where it gets a little bit different. In order to find the least common multiple, we need to prime factor them and then take the greatest powers of each of the numbers. Now, we say greatest powers, that would be, so 2 over 3 is the biggest of the 2's. There's 2 3's, so we take the biggest one. There's 1 5 and 1 7. So we would take those numbers together and then multiply them all out to find my least common multiple. So appearing in the factorization, so my least common multiple is going to be 2 to the third, 3 to the second, 5, and 7. multiply those all out in my calculator, it comes out to 2520. So a little bit easier, more scientific way of doing things. So the least common multiple of 168 and 180 is 2520. All right, you try, go. Okay, so I'm going to prime factor the two things out. So I'm going to go 96 and 144. 144 is going to be 12 times 12. And those are going to be 3 and 4. So I can say 144 is going to be 3 squared and 4 squared. 96, let's put that one out here. Okay, so that would be 2 and 48. This would be 6 times 8. 8 is 2 cubed. And 6 times 8 is going to be 2 times 3. So lots of 2's here. So I got 3, 4, 5. So it's going to be 2 to the 5th. And then 1, 3. So my biggest ones, so that'd be 96. My biggest ones are these 3. So I put those together. 2 to the 5th. Times 3 to the 2nd times 4 squared, and that should come out to 288. Should. I didn't do it out of numbers. Hopefully you came out with that one. Okay, so find the least common multiple of 2x squared, y squared, and then 6y cubed. So same basic concept here, except now we're going to have to figure out the least common of the numbers and of the letters. And the greatest of the letters. Once we get there, to come the least common multiple, you find the greatest of each factor, which totally makes sense. So this one we would pull out would be 2 squared and 3. Actually, think about this last one here. Haha, I did that wrong, because those should have been 2's. So that one would have been 3 squared and then 2 to the 4th. So this was wrong. So it'd be 2 to the 5th and 3 squared. That comes out to 288. And now back to our regularly scheduled programming. Okay, so when we prime factor that out, I come out with 2 squared, 3x squared, and y squared. So for 6y, I'm going to prime factor this out to 2 and 3. So it'll be 2 times 3 and y cubed. So then I take the biggest of each one. So there's biggest doesn't matter which one if they're the same, x squared, y to the 3rd. Put those in a line, multiply them out, put them together, and that comes out with my least common multiple. Now make sure you can read. There is a tiny bit difference there in the original, but yeah, same concept. All right, so there's what it comes out to be. Your turn, go. Okay, so I'm going to start with 18 and 24, and we're going to prime factor these out. 2 and 9, 3 and 3. I'm going to go 2 and 12. It's going to be 2 squared and 3. So it gives me 3 2's. So 18 is going to be 2 and 3 squared, and 24 is going to be 2 squared and 3. So my greatest primes are those. So my least common multiple equals 2 squared plus, or 2 squared times 3 squared, and that equals 72. Whoops, give my number there. 72. Let's see, I also had a squared on here, or a, and then b cubed, and then a squared and b. So I'd put a squared and b cubed onto this. A squared, b cubed. There we go. That's how we get it. All right, so least common denominator. Okay, we already know that we're just trying to find the least common multiple of the denominator. So I have to find the least common multiple of 8 and 20 together. So 8, if I prime factor that out, comes to 3 cubed. 20 comes out to 2 times 4, 2 to the 2nd, and 5. So my least common denominator of them both, write the prime factorization of 8 and 20, highlight the greatest power of each prime factor. So I multiply those together, it's going to come out to 40. So now I have to figure out what number times 8 equals 40, and what number times 20 equals 40? Oh, sorry, that's all they want. Never mind, that's as far as we go. Just find what the least common denominator of these two numbers is. So the least common number, that is 40, and that's where you stop for now. Pause this, give it a shot. All right, so I'm trying to find the least common denominator of 9 and 12. So 9 is going to be 3 squared, 3 times 3, and 12 is going to be 2 squared and 3. And 3. So my common ones are these. I probably should have had that over the top of that 3, but that's okay. Keep on rolling. So 2 squared times 3 squared is going to be 4 times 9, which would be 36. All right, find the least common denominator of these two numbers. So again, we're going to prime factor those two numbers and then take the greatest powers of the letters. So we're going to take 36 comes out to 2 squared, 3 squared, and then we have put on the a squared and b to that. 27 comes out to 3 cubed, and then we take the a and b squared. So then we highlight the biggest primes of each one, and that comes out to this. So we take that and multiply it all out. Now what I would do for these up here, just to make it a little easier, is I would go 2 squared times 3 squared times a squared times b, and I would line up the same ones with this. So I'd put 3 cubed underneath a and b squared, because then it makes a little more sense when you highlight or circle or whatever you want to do to know which one's the biggest. And then we put those all in and multiply them out. Pause this, give it a shot. Okay, try to keep going here. So 24 and 40, we'll start with those. 24 is going to be 2 and 12, and that's going to be 2 squared and 3, so that gives me 2 cubed times 3. 40 is going to be, I'm going to split it up to 4 and 10, and that's going to be 2 and 2, and that's going to be 2 and 5, so 2 cubed and 5. So when I put these all out here straight, so I'm going to go 24m cubed n, it's going to be 2 cubed times 3 times m cubed and n. And then my 40m numbers, so 40m n to the 5th, is going to come out to 2 cubed times 5. We'll put it over here so it lines up here. And then m times n to the 5th. So my biggest ones are 2 to the 3rd, 3, 5, m3, n to the 4th. So I multiply those all out in my calculator to get this number, and then I tack on m3 and n to the 5th, and that comes out to 120 m3 or m cubed to n to the 5th. And we're still got more, my goodness. All right, so we replace this one to make sure it's a true statement. So it's going to be tough to figure out these two without actually finding or making them into the same denominator. So we use the least common denominator of 15 and 7, which comes out to 357, which is 105. So we need to rewrite these fractions using this least common denominator in order to compare the actual numerators. So the number that changes, actually they use these, that's really smart. So they put 3, 5, and then they added on the 7, or times on the 7 onto each one to get the same prime factor, or the same denominator. So you multiply those together, multiply those, comes out to this. And we'll do the same with the other one, which is going to be 7 times 3 times 5. Let's get that all off of there. So they already have 3 times 5, so we just need to put the 7 onto it. 3 times 5 will onto the 3, so we're going to multiply that by 15 and multiply that by 15. Now we can compare 49 over 105 and 45 on 105. And since 49 is greater, it's going to point to the smaller one. So 49 is greater than 45 over 105. And we can put that onto a number line, which makes life a little easier. Pause this, give it a shot. Okay, so they're going to want you to find the least common denominator. So that's going to be 21 is 3 times 7, and 14 is going to be 2 times 7. So my least common denominator is going to be 2, 3, and 7. So 2 times 3 is 6, times 7 is 42, will be my least common denominator. So when we put these out here, I'm going to have 5 over 21, and then I'm going to have 9 over 14. To make this one into 42, so I had 3, 7, so this one's 21. So I have to multiply by 2. So 2 over 2 going to come out to 10 over 42. And the bottom one here, we need to multiply by 21. Oh, hang on. Sorry, by 3, because this already has a 7 in it. So 2 times 7, we'll do this one all the way out. 2 times 7, and then that would be 9 on the top. And we need to multiply that, so it looks like an A. So we multiply that by 3 over 3, because that's the one that's missing. So that gives us 27 over 42. So now I can put those back up here. So my one that has 21 is 10 over 21. Or 42, sorry. 10 over 42, and this one's 27 over 42. That's pretty obvious. It's going to go left. Now we're done.